When we're thinking of instrument approaches, most of us envision breaking out of the clouds with the runway right in front of us, making a minor adjustment, and then making a straight-in landing. But there are some good reasons why you might not be able to land straight ahead when you see that runway. Sometimes the approach to the airport is at such an angle to the runway that you can't land straight in. If you did land straight ahead, you'd land across the width of the runway instead of down the length, and that's definitely not a good idea. Other times the approach may have straight-in minimums, but landing straight ahead is not a good option because the wind is strong and it favors a different runway. Or you may be flying an approach that, while it is aligned with the runway, it doesn't have straight-in minimums. That happens on some approaches because you're so high at the MDA that if you didn't see the runway until you were at the missed approach point, you wouldn't be able to get down in time. You'd have to use a 45-degree dive bombing run just to land in the same county, let alone on the approach end of the runway. So what do you do in these cases? Well, you make a circling approach. A circling approach is one of the most challenging and risky maneuvers in instrument flying because on a circling approach, once you start circling, you're no longer glued to the friendly instruments in your panel. Instead, you must direct your attention largely outside the cockpit. This maneuver is no stroll in the park VFR landing. Remember why you shot this instrument approach in the first place? When you get below the clouds and spot the airport, you could still have really lousy weather, low ragged ceilings, and poor visibility. In a circling approach, you have to keep the runway in sight, maneuver for landing, and keep your airplane right side up, all at a low altitude, in possible turbulence, and with poor horizon references. So let's talk about circling approaches and how you fly them safely to either a landing or a missed approach. First, let's take a look at the ILS runway 36 approach to Green Bay, Wisconsin. As you can see, this is a straight-in approach to runway 36. But if the crosswind is too strong, remember the demonstrated crosswind component for your Skyhawk is 15 knots, or if runway 36 is closed for any reason, such as a snowplow or a disabled airplane on the runway, you might make the approach to runway 36 and then circle to land on runway 624. Anytime you plan to land on a different runway than the runway the approach was designed for, you use the circling minimums on the approach chart. Circling minimums are usually higher than the straight-in minimums. As you can see here, the straight-in ILS minimums are a DH of 882 feet and 2,400 RVR. But the circling minimums are considerably higher, an MDA of 1,160 feet and a visibility requirement of 1 mile. This makes sense since you'll be maneuvering around the airport rather than landing straight ahead. This maneuvering could have you flying over some high terrain or radio antennas in the general vicinity of the airport. Now, whenever you have to circle to land, you can no longer use your altitude on the glide slope as your missed approach point. That's because if you're going to circle, you'll stop your descent on the glide slope at the circling MDA, and that's well before you reach decision height. So in this case, you would use time to determine your missed approach point. You'll usually be able to tell when you do your pre-flight planning if you'll need to circle to land. You do that by looking at the airport information, including the available approaches and the weather reports and forecasts for the field. Now, on some approaches, the MDA on the approach won't let you get down in time to land straight in. Take a look at the Localizer D approach at San Diego's Gillespie Field. You know this approach has only circling minimums because in the title of the approach, a letter rather than a runway number follows the approach type. But as you can see in the airport sketch, the Localizer approach path lines up with runway 27 right. This approach has only circling minimums because you can't get down in time for a straight-in approach. If you didn't see the runway threshold until you were 1¼ miles out, that's the lowest visibility minimum for the approach, and you were at the lowest MDA authorized for the approach, 1,540 feet, you'd need a glide slope angle of more than 8 degrees, which is much greater than normal, to touch down at the displaced threshold. At your Skyhawk's 90-knot approach speed, that would require a descent rate of 1,330 feet per minute. Piece of cake if you're flying a helicopter. Airliners and corporate jets consider an approach to be dangerously unstable if the rate of descent inside the final approach fix exceeds 1,000 feet per minute. Now, just because the approach only has circling minimums listed, that doesn't mean you have to circle to land. If you see the runway in time to make a straight-in landing using normal maneuvers and a normal descent rate, and ATC has cleared you to land, you don't have to circle. Just make the straight-in landing. Now, when the FAA provides circling minimums on an approach, they've made sure the area you'll be circling in is free of obstacles. For aircraft in approach category A, like your Skyhawk, the FAA draws arcs with a radius of 1.3 nautical miles off the ends of all the runways. Then they draw tangents between the arcs like this. And then the enclosed area is carefully surveyed and circling MDA is set at 300 feet above the highest object inside the area. Progressively larger protected areas are created for each successively faster approach category by increasing the radius of the arcs drawn off the ends of the runways. That makes sense. The faster you go, the more geography you use up. Unfortunately, as the size of the protected area increases, so does the possibility of finding something sticking up into it. That's the reason the circling MDAs tend to get higher as the approach categories march through the alphabet. The FAA raises the minimums to keep folks out of the trees and microwave towers, and personally, I like that idea. It becomes obvious then that it is extremely important to use the correct MDA for the airspeed you're flying. For instance, as you remember, the maximum airspeed for a Category A aircraft is 90 knots. If for some reason you were maneuvering on this approach at an airspeed of 91 knots, you would become a Category B aircraft, and your MDA would go up from 1,180 feet to 1,320 feet. Now take a look at the VOR or GPS approach to runway 22 at Rawlins, Wyoming. Sometimes there is tall stuff, like, say, a mountain, poking up in one particular part of the protected area. Notice these obstructions northwest of the airport. To clear them, the FAA would have to raise the minimums to an unreasonable height. In that case, they just give up on that area and put a procedural note on the approach chart, like this one, that tells you circling is not authorized northwest of runway 422. Now that you know how much room you have available for circling, how should you get lined up with the landing runway? First, you go no lower than the minimum circling altitude until you're in a position to make a normal descent to a landing. Okay, where will you be in a position for a normal descent to a landing? That may be downwind abeam your landing position, or it could be on base leg, depending on how low your MDA is. A word of caution here. Don't forget that when you're flying at the circling MDA, you will usually be lower than the VFR pattern altitude, and often much lower. Plus, since you need to stay close enough to the runway to see it at the visibility minimum, you may be closer to the runway than you're used to. Things may not look very normal, and you may need to make a continuous 180-degree turn rather than a defined downwind, base, and final. It helps a lot to slow down. If you've slowed down to 75 knots in preparation for the landing, the diameter of a standard rate turn will be about 4,850 feet, almost out of sight if you have 1 statute mile visibility. Steepening the turn to a 20-degree bank brings that diameter down to 2,750 feet, and 25 degrees of bank will get you around in 2,150 feet. But the steeper your bank, the greater the chance of some problems. Because you're flying in low visibility, it's very easy to get disoriented, so you'll want to refer to your instruments to monitor your altitude and bank angle. Now, the FAA suggests several ways to get lined up with the landing runway. The general rule is to get onto the downwind or base leg using the shortest path. If at all possible, choose a maneuver that puts the runway on the pilot side of the airplane so you can see it better. If your approach course intercepts the runway center line at less than 90 degrees and you see the runway in time to establish a base leg, you could use a pattern like this. This particular example has you landing on runway 6 after shooting the ILS-36 at Green Bay. Here you'd establish a right base leg and stay at the MDA until you're in a position to make a normal descent for landing. And if you didn't see the runway in time to fly a base leg, you could overfly runway 6 and then turn to the downwind, as you see here. You could use this pattern when your landing direction will be opposite the approach path and you've sighted the runway in time to enter the downwind leg. That would be the case if you'd be landing on runway 18 here at Green Bay. You'd simply slide over to offset the runway and fly the downwind leg. And once again, you'll go no lower than the MDA until you're in position to make a normal descent for the landing. Finally, you'd use this pattern if you sight the runway too late to slide over and enter downwind in order to land in the opposite direction. This pattern has you overflying the runway, then circling upwind, crosswind, and then onto the downwind. Before you choose which pattern to use, you should always check the notes area on the approach chart for any restrictions on circling. Of course, when you're landing at a controlled airport, ATC may ask you to do something different than these recommended patterns. When you're landing at an uncontrolled field, make your usual broadcast of position and intentions on the Common Traffic Advisory frequency. Then listen for VFR traffic. If the Class E airspace doesn't go all the way to the ground, you'd be surprised at the number of folks that might be milling around in the Class G over the airport, and they're perfectly legal. If no one responds to your calls and the ceiling is high enough, overfly the uncontrolled airport looking for wind indicators, pattern indicators, and VFR traffic, just as you would on a VFR day. It's a good idea to practice circling to land in good VFR weather conditions, so you're comfortable with the maneuvering before you need to do it for real. Bear in mind, though, that this practice may put you in conflict with other traffic and be contrary to normal traffic patterns. Now, if you lose sight of the runway while circling, unless it's due to some part of the airplane temporarily blocking your view, you should immediately begin the missed approach procedure. First, make a climbing turn towards the landing runway. You know there won't be any obstructions over the top of the airport. Then continue climbing as you establish yourself on the missed approach course. This will keep you in the protected airspace around the airport as you gain altitude while you're maneuvering. If you're lucky enough to have an HSI, leaving it set on the straight-in approach course 002 here at Green Bay will help a lot with your orientation. Circling to land is a safe procedure as long as you understand the procedures and follow them carefully. But be very, very cautious about doing a circling approach if you need to shoot the approach in the dark, in the mountains, or when the visibility is at the minimum for the approach. These conditions raise the risk level in a circling approach significantly, especially if you have them all at the same time.